A very good afternoon to this esteemed and erudite audience. I, Dr. Smita Devyavir, Associate Professor, Department of Nephrology, welcome you all to the 5th Professor K.S. Chugh Oration. I also welcome all the virtual attendees who have joined us online, courtesy PGI's Telemedicine Department. I now request our Director, Sir Professor Dr. Vivek Lal, to join the dais. And I also request Dean Research and the Head of Internal Medicine, Professor Dr. Sanjay Jain, sir, as well as Professor Dr. H.S. Kohli, the Head of Nephrology, to kindly grace the dais. Now, let's have a small trip down the historical memory lane in the form of an audiovisual presentation. was a mesmerizing piece of history compiled passionately by Professor Dr. H.S. Kohli. I will now request the Director, PGI Sir, to kindly introduce the oration.
Mrs. Chugh, good afternoon. Professor Walia, Professor Sharma, Professor Chawla, Dr. K.L. Gupta, Professor Subhash Verma, Dr. Kulhara, Professor Rao, and of course, the blue-eyed boy for today, the legend's son, Suman Chugh, our junior resident. I just told him an incident, which I'll tell you, which will introduce the legend he's going to speak on. And you can't step into your father's shoes. He was a legend. Let me tell you that. So when he became a junior resident, 87 to 1990, I was the junior resident. Sanjay Jain was teaching us. He was in full form like Rajesh Khanna, right, at that time. He used to teach us a lot. 91 to 93, you did your MD here. And Professor Chugh very clearly made it amply clear. Pull him as much as you can. Beat him as much as you can in whatever way as you can, but make a man out of him. That was Professor Chugh. That was Professor Chugh. And he made no bones of that. I should not get a report that my son's upbringing in PGI is being compromised because he is my son. Give it hard to him. Make him feel hard, but make a man out of him. So I shared these words with him today. And I was actually so touched when he said it openly. 4 of us were standing, 5, 6 of us. Anupam Agarwal was there. And Sanjay Jain was there. I was there, junior to them. And Sadiqi was there. And there was one more gentleman. I think it was Jha. So that's when he said these in front of them. Taki agar koi galti kare, the other will pick up and compensate. So Professor Chugh, I was just talking to Professor Chawla, Professor Walia, Professor Sharma. They are icons. They are icons. They midwife the birth of PGI. They converted this institute into an institution of incredible character. Incredible character. You see, I've never understood how so many brave hearts got together at that time. This defies science and defies statistics also. How so many brave hearts got together with one intention. Normally you'll have something this way or that way, but they all had this intention of creating a great institute. And they went to any extent to do that. And I think let's give them a round of applause, the front bench. Let's all give them a round of applause, because we stand here because of the giants who are sitting on the front benches. We stand here. And the aura that this institute enjoys today is because of legends like Professor Chugh. I'm telling that to you straight, without any embellishments. They would be so different, and this applies to Professor Chugh also. Agar ek kursi aati thi, एक कुर्सी भी आती थी, it was a cause of celebration. उसको प्रोफेसर वालिया बताते, प्रोफेसर चुग के साथ बैठ के उसको खोला जाता था, अपने आप खोलते थे, and that would be a cause for celebration. That were the times that they saw, and they sowed this banyan tree called PGI. This banyan tree refuses to die in spite of the colossal responsibilities that we have today on our shoulders. I'm not saying it's a burden. I'm saying it's a responsibility. The surrounding medical colleges are actually, if you see, dipping in their performance. And the responsibility commensurately falls on us. But then, as I would say, हमें उनका DNA, हमें founding fathers का DNA, हमें Professor Chugh का DNA, and we refuse to bend, we refuse to relent, we refuse to bow in spite of overwhelming odds. Sumant is no exception. Sumant, you, Anupam, Dr. Jha, Sanjay Jain, nephrology rocked in PGI. Nephrology rocked in PGI because of a rock star called Professor Chugh. He was a rock star. Those of us who have been his residents, and I was his resident, would dread him. Saturday was his OPD. Saturday used to be the nephrology OPD, and he had that 1954 stethoscope. हमको तो उससे first heart sound नहीं सुनता तो वो चारों सुन जाते थे, which we never understood. I still remember. He had that 1954 Littman stethoscope, which is always dangling around his neck, right? And honestly, I tell you, he would hear the fourth heart sound. हमसे तो पहला नहीं सुना. I made that very clear. And then you had no option but to follow the footsteps of that giant. He taught me renal biopsies. He taught me the art of treating a nephrology patient before I got sucked up into neurology. I still remember I wanted to do, but there was no seat at that time in nephrology. There was no seat in cardiology also, and I didn't want to wait. So I saw जहाँ पे रास्ता खाली है, जहाँ पे black में ticket नहीं मिल रही, I went into neurology and I got through as a neurologist. The rest is history. But whenever in neurology I got some time, I would go to his chamber, which was on second floor A block, a lithotripsy room, where you had the lithotripsy facility, right side pay. All the journals would be lying on the table. Any journal which came to PGI first came to Professor Chugh's room. And before you know he had read it, before you know he had read anything which concerned nephrology. And he invariably knew more than his students. It's rare for a professor, it's rare for a consultant to know more than his residents. Professor Chugh was always ahead of his residents. And the result was that PGI reaped the dividends of his commitment, his vision, and his passion. And this applies to all the founding fathers who have taken the time out to come for this oration. Sir, I bow my head in front of you because of nothing but sheer respect, out of sheer respect for creating a banyan tree, for creating a constellation called PGI. I take a bow again. With these words, I thank Sumant for having come. It's nice to have you over, Sumant. It's always nice to know there's a resident now who happens to be Professor Chugh's son and now is trying to step into the giant shoes of a legend called Professor K.S. Chugh, the father, the rock star of nephrology in India. Namaskar.
Thank you, Director Sir, for your heartening, inspiring, and impactful words of wisdom. I now request Professor Dr. H.S. Kohli Sir, the Head of Nephrology, to introduce the orator for today's session, Dr. Sumant Chugh.
Thank you, everyone. After those very strong words which came right from the heart of Professor Vivek Lal, maybe my introduction may seem a little downplayed, you may say so, but I think it's a pleasure duty to introduce Dr. Sumant Chugh. Now, Dr. Sumant Chugh is at present the Dr. Andrew and Peg Thompson Endowed Professor in Internal Medicine at Rush University and also the Principal Investigator of the Glomerular Disease Therapeutic Lab in Chicago, of course. He trained in internal medicine at PGIMER Chandigarh, as mentioned, during 1991 to 94, and obviously then followed in the footsteps of his father, Professor K.S. Chugh. And then he trained, of course, not here, but at the Boston University Medical Center during 1996 to 1999. When I thought that I have to introduce the orator, and that to a father and son, I was reminded of, I have a book with me which I keep on writing all the quotes which I like. So this was something a century ago in 1870. Karen had said that my father didn't tell me how to live. He just lived and I watched. And a century later, this is in 1970, Terry, she is in Phoenix, and she says that every son quotes his father not only in words, but also in deeds. And that's what I felt. It's a perfect combination of two things. It's not mere words, and these are the deeds which are getting reflected. And this could be because of, as Dr. Lal said, आदमी बनाना है, बंदा बनाना है. Maybe because of that. That's what Sumant has done. He has been a NIH-funded principal investigator since 2001. Now, that's a long, long period. It's not an easy job. He has been awarded 25 research grants during his career, mainly from US NIH. He's a world leader in glomerular diseases, its investigations, and then also therapeutics. And he has been instrumental in bringing and to the attention of the nephrology community the major molecular pathways, especially in minimal change nephrotic syndrome. And he also established the glomerular disease therapeutics labs in 2007. He's a member of American Society of Clinical Investigation, and he's a proud recipient of Max Cooper Award. Well, Max Cooper, he himself was awarded a Lasker Award, and Max Cooper is the one who discovered B cells. So that's an amazing achievement in itself. Dr. Sumant has numerous publications in leading scientific journals, Nature Medicine. Now, this journal I cannot forget because Professor Chugh showed us, all of us, even he was not in the department, this article, especially in Nature Medicine. I think he must have shown to the whole of Indian nephrology. So much pride was there on his face when he showed this journal to all of us. And also Journal of Clinical Investigation, Kidney International, NEJM. And he's currently a PI in 3 R01 grants. Now that's another not a easy task to get such grants. And of course, his lab is there, and he's a co-investigator in a number of projects. And then also, I don't know how he got this bug of marketing or somehow to start up his own company, the GD therapy, the glomerular disease therapy, and he had 6 patents filed in different fields. So that's just a brief introduction about Dr. Sumant Chugh, the orator for 5th Professor Kirpal Singh Chugh Oration. Now, Dr. Sumant Chugh will be showing us how he plans to make a difference in the world, in this nephrology community, especially about the treatment of kidney diseases in the near future. May I invite now Dr. Sumant Chugh, please, to deliver this 5th Professor Kirpal Singh Chugh Oration. Dr. Sumant, please.
Well, good evening, everyone. Well, thank you so much, Director, Dean, and Dr. Kohli, distinguished former directors of the Postgraduate Institute, distinguished current serving and emeritus professors, faculty, students, trainees, postdoctoral fellows, my dear friends in these rows, and my dear family, and foremost, my mother. Thank you all for being here, and I'm going to talk a little bit first, very briefly, about this man. So this is a picture from 6 decades ago, and I can tell you, Harbir, you couldn't have gotten, you couldn't have captured this picture. It was lying in my personal family album, so I had it. So this is the giant that we are talking about, and if you look at this one picture, it summarizes everything. You can see a person in a state of perfection, a person who thinks forward and he wants to make a difference, a person who's a deep thinker and is immaculately dressed. So this was my father, Professor Kirpal Singh Chugh. This is my disclosure slide. This is a standard slide. I have a startup company. I'm a professor at the university, and I have a startup company, and I have multiple intellectual properties. Now, this is a picture of him and me. So you can guess who is him and who's me, right? So one of the things I have to tell you is that he was very inspirational. And even if he liked your idea a little bit, you'd say, you know, try it out. Go ahead. Don't be scared. Just go and do it. So at some stage 5 decades and 7 years ago, he and I are having a conversation of some kind, and it appears that I asked him a question and he likes it and he says, sounds like a great idea, go for it. What the idea was, I have no idea. But that's what it sounds like to me in this slide. So I'm going to take you guys a little bit through a journey that sort of begins with PGI, because there used to be an epidiocese there and I used to hide behind that when I was a resident. It's no longer there. Let's look at how I started. So there was the residency at PGI, right? And then nephrology fellowship at BU. And, I had my usual academic ambitions, but I had a little twist, right? Training at PGI, you don't, in those days at least, you wouldn't be trained in basic science. So I wanted to do nephrology, but I wanted to do science, and I wanted to do basic science research, but not clinical research. So I mentioned this to him, and he said, "Yeah, that sounds good. That sounds good." So he gave his blessings to me. Oh, just go ahead, and try something different. So I decided to adopt a career in basic science, and then I got my first NIH grant in 2001 to 2006, and I moved to Northwestern in 2000, 2001. And then, for the first time, I had a first author paper in the Journal of Clinical Investigation, which, it's a reasonably prestigious journal, and I was sort of thrilled. I was, high in the clouds because it's a tough journal in those days to get into. And so, but this was also the only study that I have done in my lifetime based on somebody else's ideas. My whole concept was, what am I going to do? So I decided, you look at the literature and you see that there are no cohesive explanations of glomerular disease. So I decided to work on glomerular disease and proteinuria, but at the same time, I decided to start from scratch. I decided to do my own discovery phase studies and develop a field as it came to me, right? So the first part of this, between 2000 and 2007, I cloned 2 genes. One was rat zinc fingers and homeoboxes 3. And I discovered the upregulation of this very interesting protein, angiopoietin-like 4, in glomerular disease. And at that stage, I would say I was still on a very traditional academic trajectory. I'm already an assistant professor. I have to become an associate professor. I have to get more grants. I have to get funded, write more papers. And then, when I was flying high, then I sent the next paper. I said I could get into JCI, now let me try science. So I sent a paper to science, and of course, it got rejected promptly from science. So anyway, it brings you down. Okay, buddy, you're flying too fast. Come down. So, that got published in 2 other decent journals, JBC and Kidney International. And then I got my first R01 in 2007, and I had to make a decision. What am I really going to do? And I thought about it, and so I decided that I want to be a therapeutic scientist. Right? So I have already done discovery phase studies, and I'm going to develop the future therapeutics for human kidney disease. So at that stage, I moved down south from Chicago to the University of Alabama at Birmingham, and then I founded the lab that I currently run and work in. And so what really is a therapeutics path career? So a therapeutics path career is very different from a clinical career, a clinical research career, and a basic science career. People think that it's just an anomaly of the basic science career. It's actually not. So if you look at the characteristics of a therapeutics career, you do your own basic science discoveries. You have to be at least 20 years ahead of the clinician, at least. And you have to be at least 10 years ahead of the classic common garden basic scientists that you're competing with. That is the first basic principle of being a therapeutic biologist. You have to focus on filing patents based on your science. There are no abstracts. Abstracts in the patent world are prior art. So you go directly from science to publication without abstracts. You have to set up a startup company at some point in time. No curiosity-related projects. You have to be focused. You have to work longitudinally towards your therapeutic goals. And then the most important priority in life is to preserve your funding. So you do whatever you can by doing good science to preserve your funding, and you actually give that priority over honors, recognitions, academic awards, and leadership roles. And typically you attend large meetings like the ASN and the ISN. You don't attend them for the science. The science at these meetings is already about a decade behind yours, right? You attend these to meet people. So it's very important. So that was, that was the sort of, you have to slide into this career. You just don't say, I'm going to do this, just this and nothing else. So you sort of slide into it and then transform yourself. So our first landmark paper that Harbir just mentioned was Nature Medicine, and my father was extremely proud. And then, at the same time, we filed 2 IPs, 2 patents. And I also started GD Therapy as a startup company. And then in 2014, I had another landmark paper in Nature Medicine, and 2 more R01s came in. And then, the whole idea was, where am I going to move this forward, right? So then I wanted to sort of move to a larger city, and so I moved back to Chicago. And then, I saw the last vestiges of my classic academic career, the tail end of it, take shape as a vice chair. I was working with the dean. But by 2019, I had given that up. And so I stopped seeing inpatients in 2016. Even now, I see just outpatients twice a month. But, the good sense is that the GDTL, the Glomerular Disease Therapeutics Lab, has exploded. I was the only PI. Now we have 4 PIs. All of us are funded. We have currently $12.5 million in NIH funding at the GDTL. So, you have to leave some parts of your past life behind. You cannot take everything with you. You will fail. That is the absolute truth. And there is a lot of sacrifice to be made in the therapeutics career. And during this time, we filed 4 more patents as well. So all said and done, what have we done so far about human kidney disease? So I'm going to start by telling you about our work on minimal change nephrotic syndrome. This is currently the only glomerular disease where you have a complete pathway almost entirely shown by our group over the past 20, 25 years. Not membranous nephropathy, not FSGS, not diabetic nephropathy, but we have, starting with the 2011 paper Nature Medicine, where we showed upregulation of angioportal-like 4, and then we worked on the ZHX proteins, how they regulate. Then we found the first genomic defect in minimal change disease, and it's not in the exomes. It's 500,000 base pairs above the ZHX2 gene. And then we developed a model for a common cold-induced relapse of minimal change nephrotic syndrome. How common colds can cause relapse of nephrotic syndrome, especially MCD and FSGS. So this is one of our fundamental contributions to kidney medicine. And if any of you are trainees or young faculty, you could read this review where we have put all the aspects of human minimal change disease, how to explain what. Why does a common cold cause relapse? What are the genomic defects? What is hyposalivation injury? All of this is sort of put together in this one review. Sorry. So the next contribution to medicine is explaining the components of nephrotic syndrome. So in the 2011 paper, the 2014 paper, we showed the molecular basis of hypertriglyceridemia and nephrotic syndrome. My colleague, Dr. Clement, who is also PI at GDTL, in 2020 showed how hypercholesterolemia of nephrotic syndrome actually originates from the cortical collecting duct in the kidney. So PCSK9, which is a major mediator of hypercholesterolemia, is actually a chaperone protein for ENaC, which is the sodium channel. And as sodium absorption goes up in nephrotic syndrome, you need more PCSK9 as a chaperone to move the ENaC components to the cell membrane, and that PCSK9 gets secreted into the circulation. And that is what really initiates hypercholesterolemia and nephrotic syndrome. There is an established phase of nephrotic syndrome that is mainly liver mediated, but the initiation of hypercholesterolemia is actually in the cortical collecting duct of the kidney, and that was shown by our group. In the 2011 paper, we showed some pathways in proteinuria And we are working avidly towards these two factors. So everybody knows about sodium retention and edema, but virtually nobody knows what increases peripheral permeability in edema. So we're still working on that. And everybody knows about hypoalbuminemia, but nobody can tell you why why is the albumin promoter suppressed? Why can it not compensate and induce hypoalbuminemia? So we continue to work on these things. So the third thing is, our third major contribution is we have now developed, which is what is perhaps the only credible animal model for COVID-related multi-system injury. So when the pandemic broke, so between 2015, 2016, and 2019, we had already developed common cold cocktails to induce a relapse of human minimal change disease. So when the pandemic broke in early 2020, we were the only kids on the block that had actually developed cytokine storm cocktails and tested them, but we hadn't published them, so nobody knew about this. So the original Wuhan patients, I looked at the cytokine profile of the original Wuhan patients published in a supplement in Lancet in February, and I looked at the cytokine profile, and what you see there is that there is a huge component of the allergy pathway cytokines, IL-4, IL-13. So we modified the common cold cocktails and developed COVID-19 cocktails. We developed 4 COVID-19 cocktails, which we would then inject into mice and induce either mild disease. Mild disease causes only mild proteinuria. You see that all the time in COVID patients. You know, they had 1+, 2+ proteinuria. The disease gets better, the proteinuria is gone, right? But then you injected more, you could get moderate disease and severe disease. And the severe disease was like the COVID ICU patients in distress and with multi-organ system failure. The moderate disease was more like a patient admitted to the hospital, perhaps with less important or less sort of more minor abnormalities, a little bit of myocarditis, a little bit of pericarditis, but not really in the ICU. And so this is probably the only model after over $1 billion was spent developing real animal models of COVID during viruses. This is the only model which has no virus injection. It's a model of extrapulmonary manifestations of COVID that actually explains myocardial injury, myocarditis, pericarditis, liver injury, acute kidney injury, glomerular injury, all of which you see in the COVID spectrum. So this was our third major contribution sort of to the literature. So I'm going to now go into the areas that I thought I would speak about today, and that is my focus on therapeutics. And so I'm going to talk about therapeutics in chronic kidney disease with a focus on FSGS, focal and segmental glomerulosclerosis, and diabetic nephropathy. And the second time, I'm going to talk about minimal change disease. And then I'm going to show you how we have managed to at least experimentally manipulate and eliminate mortality in viral cytokine storms. So here is our paradigm for the treatment of chronic kidney disease. So in the published literature, in the discussed literature, in the usual up-to-dates and this and that, the concepts I'm going to discuss with you do not exist. Because what the published literature shows you is as follows. You get kidney injury from any of these causes, right? Hypertension, diabetes, a variety of causes. All of them can cause kidney injury, and then they can also injure the repair vessels. So what are repair vessels? These are blood vessels that resupply the kidney, right? That's the circulation going into the kidney during injury. So any of these insults would induce, say, both tubular injury, glomerular injury, whatever, as well as, endothelial injury, repair vessel injury, right? And so if you treat them with classic drugs like ACEs or ARBs or SGLT2 inhibitors and GLP-1 agonists, what you're going to do is this 3+ injury here is going to become like 2+, right? And then there's also a little bit reduced injury to the repair vessels. So all of this 3+ becomes 2+, and you get slower progression of CKD. and you have a reduced incidence of ESRD. So to get this separation of curves, I mean, with ACEs and ARBs, it takes many years, but I think with the SGLT2 and maybe even with the GLP-1s, it's a couple of years. The curve starts separating at a couple of years, right? So within 5 years, these kind of drugs that have this partial effect are going to be a dime a dozen, right? We have, over the past 10 years, not even made this our goal. What we have tried to do is develop only those biological therapeutics that will actually interact here, that actually can keep the repair vessels open, right? And also reduce kidney injury, just like these other drugs do. So we have mutated this protein called angiopoietin-like 4, right, to develop a biological therapeutic that will then keep the repair vessels open, reduce intrinsic kidney injury, right? Some of these are mediated through integrins. Some of these are mediated through syndicans or other proteoglycans. And this is a multi-compartment effect. So our goal is actual reversal of CKD. We have never, even though all of pharma, all of literature is talking about reducing the progression of CKD, our goal has always been reversal of CKD. So that is, if you run a high-stakes therapeutics lab, that's how one has to think. And so our goal is to actually reverse CKD. So you're going from CKD4 to CKD3 and CKD3 to CKD2. And our goal is to make ESRD obsolete. You can't eliminate it, but that's what our goal is. So I'm going to show you some proof of concept studies. Maybe it's a little bit too much, but these are buffalo amino rats. They get FSGS spontaneously. They become proteinuria by about 6 weeks. And after 7 weeks, after 7 months, the creatinine starts going up. So these are buffalo amino rats here. And you see the creatinine starts going up at 7 months, 8 months. And in the dark gray bar is buffalo amino rats that have a transgene in the adipose tissue that secretes a lot of angiopoietin-like 4, just wild type rat angiopoietin-like 4. And what you see is that by the age of, it's down here, but it's not statistically significant. By the age of 8 and 8.5 months, the creatinine in these rats, in the transgenic rats, buffalo amino, is much lower. Same with the BUN, same with the 24-hour proteinuria adjusted for GFR. And incidentally, the cholesterol actually declines much earlier because of preservation of tubular function, right? And what you see is that the tubular interstitial fibrosis is practically gone. And then what you also see is that the tunnel positive cells in the endothelium, in the interstitial endothelium, are markedly reduced in the transgenic buffalo amino rats. So it takes a little while for the slide to move. But yeah, so what happens is that the angiopoietin-like 4 is now working to reduce the fibrosis by preserving the repair vessels here. So these are the buffalo amino rats, and Dr. Joshi could probably buy for that. This is a Mason trichome strain, and showing fibrosis here, no fibrosis here. And this is just the growth section where they have fibrosis and no fibrosis. So this is a proof of concept study on how such a biological would work. So then what we started doing was we started injecting this mutated protein into diabetic rats, right? And we started with a very, not a very high dose, but a moderately high dose, 500 micrograms subcutaneously every week. We make and purify all these proteins ourselves. And then by the time it's 35 days of therapy, which means 5 weeks of therapy, the creatinine is already
like to also thank the former faculty members, Professor K.L. Gupta sir, for joining us, and this shows their special unbreakable bond with PGI. I thank all the present faculty members, the residents, and all of the staff of PGI, as well as the virtual attendees. Now, arranging the oration in the honor of legendary Professor Dr. K.S. Chugh is a humongous task in itself. I thank PGI administration, the engineering branch, and the telemedicine department for contributing to their best to make this event successful. My special thanks to my very own department, the team Nephrology, which is headed by Professor Dr. H.S. Kohli, and we are extremely proud of that. I would now request you all to join us for a cup of tea. Thank you so much. Have a great day.